All right, we're going to look at solve quadratic equations by factoring. So we've been doing the factoring pieces. So now we're going to look at actually solving that quadratic. And what it's going to use is this property: if a times b is 0, then a equals 0 or b equals 0. Now, the nice thing is for you, this is a property that you know. There's nothing new here. As far as the reason why I say you know it is because if you multiply something by 0, you get 0. You know that already. Right? So if I looked at something that was, say, already in a factored format, something like this, I just said solve, I had something already factored, like x minus 4 times x plus 2. Gone through the process, gotten it factored out, and it was equal to 0, and I'm asked to solve this. Well, this would mean that a, in this case, would be the x minus 4, b, the x plus 2. So one of these two parts, if not both, would have to be 0 for this to be true. So the way that I'll set it up is I'll set each part equal to 0. So either x minus 4 is equal to 0 or x plus 2 is 0. That means x equals 4 or x equals negative 2 when I subtract that 2 over. So again, let's get another one up here. Let's say I had it factored out and I've got x times 3x minus 5 equals 0. So there was my factored piece. Well, this would mean there's my product. So these two parts equal to 0. Either x equals 0, well, that one's already solved, or 3x minus 5 is 0. Add my 5. 3x is 5, so then x is 5/3. Another one. So looking at something that's been factored down. Let's look at a couple more. Another one with a fraction here. Let's go 2x minus 1 times 4x plus 5 equals 0. So I'm going to set each part equal to 0 to solve. 2x minus 1 is 0, or 4x plus 5 is 0. I'll solve, add my 1. 2x is 1. So x is 1/2. There's one solution. Subtract my 5. 4x is negative 5. X is negative 5/4. There's my second solution, my two solutions from that factored form. Now, most of what we're going to see is not going to be in a factored format. So let's look at some where we have to factor. Now, the nice thing for us, the factoring is not any different than we've done before. I've got x squared minus x minus 6 equals 0. I need it in this factored format. So what I'm going to do is go back, use my factoring skills, get this factored. X plus, x minus. Let's see, that would be a minus 3 and a plus 2. So going back to the factoring step that I've learned before, nothing new on the factoring. Now I've got my two pieces. X plus 2 is 0. X minus 3 is 0. So x is negative 2. Or x is 3 for my two values. So I'm looking at the factoring piece. Now, one thing that becomes important is I need to make sure I'm going through my factoring rules. My factoring rules are, if there's a common factor, get it out of there. Okay? Then if it's 4 terms, I'm thinking of grouping. 2 and 3 terms, like this one was. In my sign pattern, split the front, back, check. So I look at number 5 here. My first rule is still that common factor. My common factor here would be a 3 and an x. A 3 and an x. So I'm going to take a 3x out. That would leave me with 2x minus 5. Always look for a common factor first. Now I've got my two factored pieces. I'll set each one equal to 0. 3x equals 0. 2x minus 5 is 0. Solve each part. Divide by 3, x is 0. There's one of them. Add my 5, 2x is 5. X then will be 5 over 2. So binomial, trinomial type, in this case trinomial. Common factor. Let's go with this. X cubed minus x squared minus 25x plus 25 is 0. So we're reviewing a little bit of the factoring at the same time. So nothing in common here between the four terms. X cubed minus x squared minus 25x plus 25 is 0. Now I'm going to go through and get this factored. All right, so this was four terms. So what I'm thinking of is a grouping factor. I'm thinking of a grouping, so I'm going to group the first two and last two together. X cubed minus x squared plus negative 25x plus 25. Then I'm looking for common. I can take out an x squared. That leaves me x minus 1. I can take out a negative 25. Never leave with a negative. That leaves me x minus 1. So now I have that x minus 1 in common. X squared minus 25. Now there's one of those binomials. So that's still a quadratic. I need to factor that down. So this is going to be x minus 1, x plus 5, x minus 5. If I set each piece equal to 0, x minus 1 is 0, x plus 5 is 0, x minus 5 is 0. So I'd have x equals 1, x equals negative 5, x equals 5. 3 answers there. Now, one of the things that we'll talk about later on that kind of comes into play here, your highest power will always tell you how many answers there are. So if the highest power is 2, 2 answers. 2 answers. The highest power is 3, 3 answers. Okay. Let's look at a couple more here. Let's go number 7 here. I've got x squared minus 8x plus 16 is 0. Back to that trinomial. Nothing in common. Split the two binomials. Sign pattern this time. Okay, kind of review our sign pattern here. When we had this one, if the last term was negative, it's one of each. Now the last term is positive, so they're the same. Look to the middle, both minus. Split the front. 16's 4 and 4. Check. That gives me negative 8x. Set each piece equal to 0. X minus 4 is 0. And so I'd have x equals 4. Now they're both x equals 4, so you don't really have to write it twice. You can just write x equals 4, but there's really 2 there. So it kind of goes back to what I was saying. If the highest power is 2, then there is 2 answers, but you could have a repeater. So there's really 2 answers here. It's just the same one repeating. Now, one of the things to notice in any of the problems so far, they've been all equal to 0. So if you get one that's not equal to 0, my very first course of action would be make it equal to 0. So if I've got this one, 3x squared plus 5x equals 2. Can't go through the factoring process until I get this equal to 0. So I'm going to subtract the 2 over. 3x squared plus 5x minus 2 is 0. Then I'm looking to factor. So I need it equal to 0 first. There's that trinomial. Nothing in common. It's got to be a plus and a minus. We know when we get a number other than 1 in front, it takes us a little bit longer to factor, but I know it's a 3x and an x. It's the only way I can split up a 3. 2 would be 1 and 2. 1, 2, -6, +1. That's -5. That's the opposite of what I wanted. So remember, that tells me to switch my signs. There's my +6, -1. Now I set each piece equal to 0 to work my solving. So on the first one, I can add the 1 and divide by 3. So if I add 1, divide by 3 here, x would be 1/3. Subtract 2, x would be -2. There's my two solutions there. Let's give another look at 1 not equal to 0. So remember, we always want it equal to 0. Well, this one's a little bit tricky because I haven't factored an equal to 8. In order to solve by factoring, I have to have it equal to 0. Right? So I need to bring that 8 over. So I'd have x plus 4, x minus 3, minus 8 is 0. Now you're looking at it, gosh, I've never factored anything like that before. I haven't either. I need it back in this polynomial format. I need it to look like this guy. So what I'm going to do is multiply this back out so I can incorporate the 8 with it. So if I multiply this out, I get x squared minus 3x plus 4x minus 12. And here comes that minus 8 on the end. Combine all my like terms, x squared plus x minus 20. Now I'm in that polynomial format, equal to 0. Now I'm ready to go through and do the factoring. X plus, x minus, front's got to be x and x, plus minus, plus 5 minus 4, -4 and 5 is 1. That gives me my factoring. Then I can set each piece equal to 0. All right, so we've got to make sure, let's see if we get this down. X is -5 and x is 4. All right, nothing new in the factoring. What I've got to make sure of is that it's equal to 0. Once it's equal to 0, I can go through my normal factoring process. If there's a common factor, I get it out of there. If it's 4 terms, I'm thinking grouping. 2 and 3 terms, following my sign pattern, going forward from there. So we had a 2-term one right here. X squared minus 25. Sign pattern plus. Look at middle, minus, minus. Get it equal to 0. I've got to have it equal to 0. Sign pattern plus, minus. Looks kind of strange here, but still get it equal to 0. Get all my terms together. Now here's what we're looking at. Back to a normal look. We got it back to the way we like it. Sign pattern, then plus, minus. Then I can go through and solve the individual pieces.